At some point, America started doing something strange. The most technically gifted coders in the country stopped dreaming about building the next Intel, the next Tesla, or the next industrial giant, and started optimizing ad auctions, writing low-latency trading systems, and shaving microseconds off order flow. On paper, that looks rational. Wall Street pays, the bonus pool is real, the offices are glossy. But underneath that decision is a bigger question that matters for the entire US economy. What happens when your best engineers stop chasing production and start chasing spread? The first answer is simple. Compensation bends talent. A 23-year-old engineer coming out of MIT, Carnegie Mellon, Stanford, or a top state school can compare two career paths in a single spreadsheet. One path is a startup with equity that might never convert into cash. The other is a trading firm, hedge fund, or quant shop offering a salary, a signing bonus, a relocation package, and the possibility of a year-end payout larger than both parents ever made in a decade. You do not need ideology to understand that flow. You only need arithmetic. But finance is not hiring engineers out of vanity. It hires them because software now is the business. Market making is code, risk management is code, execution speed is code. Options infrastructure is code. The modern trading stack is a technological arms race hidden inside a finance label. That is why elite firms fight for compiler experts, distributed systems engineers, FPGA specialists, data infrastructure talent, and machine learning researchers. They are not buying resumes. They are buying time, precision, and edge. The problem is that talent has an opportunity cost. Every brilliant engineer who spends 5 years optimizing market microstructure is not spending 5 years rebuilding power infrastructure software, industrial robotics, semiconductor tooling, logistics systems, medical devices, defense manufacturing, or energy automation. Finance can absolutely create value. It improves liquidity, pricing, and capital allocation at its best. But a country still has to ask whether marginal engineering genius is being pulled toward the highest social return or just the highest private return. This is where the conversation usually gets lazy. People turn it into a morality play about greed. That misses the real mechanism. Engineers are responding to incentives exactly the way a rational system teaches them to respond. If national policy, tax structure, prestige, procurement, immigration, research funding, and capital markets make short-cycle financial optimization more rewarding than long-cycle industrial rebuilding, then talent will move accordingly. The issue is not that smart people are making bad choices. The issue is that the scoreboard points them in one direction. Now the system may be shifting again. Artificial intelligence, defense tech, grid modernization, manufacturing software, robotics, and domestic energy are starting to offer something finance cannot always match. Mission intensity, political support, and enormous unsolved infrastructure problems. In the next 5 years, the real competition may not be startup versus hedge fund. It may be trading desk versus data center, missile factory versus quant pod, chip fab versus market maker. The new American talent war is going to be about who can make engineering feel consequential again. So here is the framework. Follow where the highest-end engineering talent goes, and you get an early map of what the United States is truly prioritizing. If the best coders keep clustering around finance, that tells you one story about incentives, capital, and national ambition. If they start moving into energy, defense, robotics, and industrial software at scale, that tells you a different story entirely. In other words, this is not just about jobs. It is a signal about what kind of economy America is choosing to build.